this week's edition of Ask NASA. I'm Kelly Gravison, and this is Catherine Murray, and today we will be interviewing Ms. Sharon Padula. Sharon is a senior research scientist in the Aeronautics Systems Analysis Branch at NASA Langley Research Center here in Virginia, and I wanted to thank you for joining us, Ms. Padula.
Very nice to be here.
Thanks. Today we'll be asking Ms. Padula about her work here at NASA and how it relates to the design challenge that our groups of engineers are working on to improve iRobot's Roomba. Throughout the interview, Catherine will be asking questions that different engineering teams have emailed in as we go through. So I guess it's time to get started. So Ms. Padula, I know that some of your work relates to optimization, and I was hoping that you could tell us a little bit about what optimization is.
Very broadly, optimization is just changing some part of the design in order to make it better. But we have to change it in a way that's practical so that it's affordable or actually doable.
Okay, and what are some examples from your research where you've used optimization?
Right now we're working on supersonic transports, so I brought a little model here. We're working on shape optimization, so how do you change the shape, for instance, where the wings are or where the engines are, in order to reduce the fuel that the airplane uses or to make less sonic boom on the ground.
So that's interesting because that research can be applied obviously to just commercial airplanes, but also things that the military is using as well, right?
Right, absolutely.
Great. And what are some other things that you've worked on?
I've worked on noise cancellation. So your students might know about noise canceling headphones. We were using this same idea of using actuators and sensors to cancel noise, but we were trying to cancel noise inside the whole fuselage of the airplane. The problem with that is where to put the actuators and where to put the sensors. After an optimization process, we decided that you could put the actuators in the walls of the fuselage, and you could put the sensors in the headrests on each seat.
Great. And I know you're doing some work with helicopter noise. Could you tell us a little bit about that?
Yeah. I think I told you earlier about our helicopter noise. We're looking at trajectory optimization for helicopters. So how the helicopter lands, what path it takes, will affect how much noise is experienced by people on the ground.
Very interesting. I think at this point we're going to stop. And Catherine, you've got some emailed questions from different engineering teams?
Yep. So the design team in Douglas is asking about the shape optimization that you've done on the supersonic transport, and they're wondering if they can apply that and somehow change the shape or design of the Roomba in order to improve its efficiency.
Certainly the circle shape is a good one, but you might want to make it bigger or smaller to increase the vacuuming power of the Roomba, but that would be very, very expensive. As far as I know, all the Roombas are the same size and shape.
So you hear that, guys? We probably don't want to look at changing the actual shape. That's going to impact our cost. The team from Seattle is wondering, they're thinking about the noise-canceling headphones and location of the sensors and actuators, and they're wondering if looking at changing the location of those on the Roomba might improve its optimization.
Yeah, you can see one of the sensors right there, and there's several underneath that sense how much dirt it's pulling up. I think you could run tests with sensors and actuators at different spots and see which one worked the best. But there again, that would be expensive.
So you're talking in terms of the design process, actually testing or running a simulation?
Well, you could make a simulation. That would be cheaper.
Okay.
I bet they already have some.
Okay. All right. And our last question's coming from Boston, and they are thinking about your helicopter landing, and they're wondering, is there a way to improve the path that the Roomba is taking so that it is more efficient in its cleaning of the room?
That's a good idea. You actually can program the Roombas. And right now, I think what it does is basically random. You could watch it, but I think when it gets into a tight spot, it picks one of its possible motions sort of at random to see if it can get out of that spot. It might be possible to actually have a better trajectory optimization that would clean the room faster and better.
Okay. All right, well, I'll let you know if we have any more questions come in from the guys in the field.
Great. Well, I have a few questions. You talked a little bit about running tests and simulations, and I was wondering what types of tools you actually use to do your work.
Actually, we use little models like this, which is why I have them. So when you're first talking to the team about what you're going to do, it's very often easy to just have a model, draw things out on the floor, try to figure out what the real problem is, and then you go back and simulate it on the computer.
And those simulations, do they work a lot like, the computer games that kids are playing all the time? Is it similar in some way?
Actually, a trajectory path for a helicopter is exactly like a computer game that you might have seen. But we also have simulations that simulate the noise at microphones on the ground.
If I can just interrupt for 1 second. The team in Chicago is wondering, where do those simulations come from? Who develops them?
Very often the engineers, I'm a mathematician, so I go out and work with a team of engineers, and very often they already have the simulations that I can modify a bit for my work.
Interesting. And speaking of that, you said you're a mathematician, so what is your educational background that brought you here to NASA?
I have college degrees, BS and a master's degree in applied math.
In applied math, but you're working with people who have degrees in science and engineering and technology,
Physics, chemistry, engineering. Yeah.
And I think you talk a lot about working in teams with groups of people.
Absolutely. It's almost always we work in a team, at least to get the initial ideas and then go back and work on your part of it.
And what would you say is the best part of working in this NASA environment?
Well, I like learning something new every day, and as you can see, I'm working on a different kind of project almost every day. I also like the people that work here. They come from literally around the world.
Great. And do you have any advice for students who may want to pursue a career in science, technology, engineering, and/or math?
Yeah, I think the students should just follow their interests. Doing any kind of engineering is very much like being on the internet, and you find one link that leads you to another link that leads you to another link. And if they just start following those links when they're still students, that's how it happens.
Great. Did we have any more questions from our emailers?
Nope, they are anxious to get working on their projects and start applying some of the information that Ms. Padula has shared with us.
Great. Well, thank you very much, Ms. Padula, for joining us, and I hope you all join us again on the next edition of Ask NASA.